Now let's look into some of the key terms for ANOVA. So pairwise comparison. Pairwise comparison is nothing but a hypothesis test between two groups among multiple groups. Okay, that's called a pairwise comparison. And an omnibus test, a single hypothesis test of the overall variance among multiple group means. Single hypothesis test of the overall variance among multiple group means are known as omnibus test. And decomposition of variance, separation of components contributing to an individual value, example from the overall average, from a treatment mean, and from a residual error. Then a statistic, a standardized statistic that measures the extent to which differences among group means exceed what might be expected in a chance model. And SS is nothing but sum of squares, referring to deviations from some average value. So now it's time for Tukey's HSD. HSD is nothing but honestly significant difference test. So Tukey's HSD, honestly significant difference test, is a post hoc analysis that can be used following an ANOVA to determine which pairs of group means differ significantly from each other. So this test takes into account the multiple comparisons problem by controlling for the family-wise error rate, which is the probability of making at least one type 1 error across all pairwise comparisons. So the HSD test calculates a critical value for the difference between means called the honestly significant difference. So the HSD test calculates a critical value for the difference between means called the honestly significant difference value. If the difference between two group means is greater than HSD value, then we can say with a certain level of confidence that the difference is statistically significant. I'm repeating this again. If the difference between two group means is greater than HSD value, then we can say that a certain level of confidence that the difference is statistically significant. The HSD value is calculated based on the number of groups being compared. So the total number of observations and the significance level is alpha chosen for the test. So the Tukey HSD test can be performed using the statmodels.stat.multicomp module in Python. So it requires the group means and the standard deviations as well as the total number of observations and the number of groups being compared. The test outputs a table of all the pairwise comparisons. The test output, the Tukey's HSD test outputs all the pairwise comparisons along with their corresponding p-values adjusted for multiple comparisons using Tukey-Kramer correction. So overall, a Tukey's HSD test is a powerful tool for identifying significant differences between group means after performing an ANOVA, and it helps to avoid the problems associated with multiple pairwise comparisons without compromising the overall alpha level. So let's look into the example now. So this is what so we have done the ANOVA for this data set, and these are the results. As per the results, temperature, humidity, effect on temperature and humidity effect on dependent variable is significant. You can see that F statistic is large, and probability p-values are smaller. Clear? Then there is an effect between the groups also, because that F statistic also larger, and also there lesser p-value, lesser than 0.05. So but we need to confirm. So we need to confirm this. How can we do that? The Tukey's HSD test is a post hoc analysis that can be used following an ANOVA to determine which pairs of group means differ significantly from each other. That's what we are going to do here. So statmodels.formula.api import OLS and SM both. So data has been loaded. So once the data, after the data has been loaded, then you have to fit into the model. So it's been fitted into the model. Now let's perform Tukey's HSD test. That's a honestly significant difference test for temperature first. We are doing for the temperature or the temperature with growth rate. Obviously growth rate is our dependent variable, so it will be doing temperature with growth rate and humidity with the growth rate. And first we'll perform Tukey's HSD test for temperature, and that results we can see here. And then second one, we'll perform Tukey's HSD test for humidity, and that's what we see. Tukey's results So first one with the temperature that you can see here. Group 1 in temperature, we have a group 1, a group 2, two groups were made. And even for the humidity, group 1, group 2. So group 1, high, low. And then let's directly look into the P. Okay, P adjusted is 0.0. P adjusted is 0.0. The HSD value is calculated based on the number of groups being compared. So the total number of observations and the significance level chosen for the test. So if the difference between two group means is greater than the HSD value. So this is the mean difference. And so Tukey's HSD, it's 0. Of course, our value is 0.05. If 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 this mean difference is greater than Tukey's HSD value, so you got the lower and then upper. If it is greater than this, then obviously you have to reject it. Okay, you have to reject the null hypothesis, and you can see that, you can say that there is an effect. There is an effect from this. So from the temperature, you got the group 1, group 2, so both are true, means you have to reject it. But when it comes here, you can see that the mean difference is no more greater than the upper limit. Upper limit, you see that? Its upper limit is 0.3752, and here the main difference is not even greater than upper limit, and then it's not even greater than upper limit. Oh, this is 0.288, it's positive. So these are all lesser than, that's why reject. So for the humidity, we will be accepting, or we'll be confirming the null hypothesis. That means there is not much of effect on the dependent variable from the humidity, but there is a huge effect. We are confirming the effect from the temperature on dependent variable, which is growth rate. So here with this result, what is the result? What is the conclusion from the ANOVA? The conclusion from ANOVA is temperature and humidity. The effect of temperature and humidity on dependent variable growth rate is significant. That's it. That's it. But We just want to confirm that significance. Then I have gone for the Tukey's HSD test, which is honestly significant difference. Then what it is saying, there is a significant effect on the growth rate from the temperature, but there is no significant effect from the humidity on the temperature. Hence proved one has been completely neglected, one has been completely ruled out, and then temperature is stayed with us. So that's how we leverage the Tukey's HSD test. So overall, Tukey's HSD test is a powerful tool for identifying significant differences between group means after performing an ANOVA, and it helps to avoid the problems associated with multiple pairwise comparisons without compromising the overall alpha level.